Here we have a bowler who is kicking his bowling ball off the edge of a cliff. That is height h. To determine the values of the distance it went, knowing the initial speed, we use this equation here. We find the time it took for the ball after it was kicked until it was landed, and then we can find that by just plugging in the initial values here. In addition to the initial values like h and v sub 0, we have acceleration in the y direction, also known as gravity, which is always in effect. But there is no acceleration in the x direction. We can use these equations here to predict where the bowling ball will land after it's kicked. But since there are forces like air resistance, this bowling ball will not land here, but it will land somewhere here with a projectile more like this instead of like that. So here we're going to learn how to find v sub 0. So we know the height, the distance the projectile traveled, and gravitational constant. So by using this equation, h equals 1/2 gt squared, we will find the time. And time is going to equal 2 h over g. After we solve this equation for time, we're going to plug in the initial values. Now that we know time, we can solve x equals v sub 0t for v sub 0. Then we plug in the values that we've found, and we'll find initial velocity. Now that we know how to solve for v sub 0, we are going to test this with the Nerf gun. The Nerf gun is 1.35 meters above the ground. It's going to be fired at the horizontal and it will hit the ground some x meters away. Now we are going to fire the bullet, determine x distance so we can find v sub 0. After the demonstration, we found that the bullet went 5.98 meters. So now we can plug our height here into our equation here and we can find the time. And that is 0.5 seconds. Calculating time, we will now plug this value and this value into this equation here to find the initial velocity. It's 11.39 meters per second. Next, we're going to add air resistance.
This is an anemometer. It measures wind speed. We made it out of popsicle sticks, Dixie cups, and pins. And so basically, when we add the air resistance to the horizontal projectile, we'll measure the speed that the fan blows the air to find the force of air resistance.
Now we'll use the anemometer to calculate the wind speed from the fan. We're going to put it a half meter away and count the number of revolutions per minute, and then use that to find the speed of the air. Now we're going to add wind to the projectile to look at the difference in displacement. We found the speed of the wind that the fan blows, and now we're going to blow it, the projectile, from behind and from in front and look at the difference in the displacement. We'll stay at the same height and the same gun and same bullet, and the only thing that will be different is the wind.
Now we will use the fan to blow the bullet from behind.
during the demonstration with the fan blowing the bullet, we found that the bullet traveled 6.1 meters during its flight path. Now we are going to shoot the dart with the wind blowing against it. In the demonstration with the fan blowing against the bullet traveled 5.1 meters during its flight path. Experiment, we can tell from our original findings, 5.9, with wind it is increased, but with air resistance it is decreased by much more.
And that concludes our rigorous physics experiment.